When it comes to highly available and fault-tolerant architectures, there are a number of areas on which to focus. But the first should be understanding the difference between fault-tolerant and highly available architectures. While the two do share some overlap, they do vary slightly in definition. Designing for high availability means designing for minimal downtime. This style focuses on reducing the negative impact to the end user by prioritizing restoration of essential services when a component or application fails. On the other hand, designing for fault tolerance means having an architecture that requires zero downtime and service interruption. It generally means higher cost due to much more replication and redundancy. This also involves much more complexity because of the management of data replication and component redundancy. And while there are differences between high availability and fault tolerance, know they are not mutually exclusive. Regardless of the style of architecture, the rest of the focus areas will still be applicable. One of those areas is determining the amount of resources needed. A lot of thought and planning needs to be given to evaluating what resources are needed. This includes the redundancy of your normal operational components, such as servers and databases, and the use of the AWS global infrastructure. But it also includes components needed to handle data replication, traffic management, failure detection, and everything else necessary for a highly available or fault-tolerant architecture. In addition to determining the amount of resources, you also need to evaluate which AWS services you can use to improve the reliability of your architectures. This is especially important with legacy applications where component migrations are not possible. If components or applications cannot be run in AWS, or you have reasons why the go-to services for something like data replication don't fit your use case, you need to know how to meet reliability requirements. Additionally, ensure you are ready to select highly available configurations to mitigate single points of failure, as well as selecting appropriate disaster recovery strategies to meet your organization's or business's requirements. When trying to determine single points of failure, it often helps to think of working backwards from the failure. What I mean by this is, when looking at an environment, take each component and assess what happens when that component fails. What happens when one of your web servers fail? What do you do when one of the application servers go down? How about the database? Evaluate these failures, then determine how you'll mitigate. And with the disaster recovery strategies, it's a bit of the same. To determine the requirements, it's common to look at the disaster recovery objectives. Evaluate the recovery time objectives and the recovery point objectives, or RTO and RPO respectively, and use those to help with deciding on which strategies will work best. In terms of strategies, make sure you look at both active-passive and active-active, as they all help to meet business needs. For the active-passive, study backup and restore, pilot light, and warm standby solutions. And for active-active, look into the multi-site active-active deployment style. These all have their ideal use cases, and they don't have to be utilized individually. Make sure you understand their strengths and how they affect RPO and RTO needs. The last topic I want to bring up for architecture reliability is identifying key performance indicators to ensure the success of your solutions. Handling high availability and fault tolerance is nearly impossible to do manually, but to automate the actions, you need to know what triggers need to be used and what indicators kick off those triggers. Understanding what key performance indicators, or KPIs, give you the best visibility into your architecture's health is important to determining when to take action. And monitoring and benchmarking are the primary ways you can know what normal operation looks like, and gives you a picture of the range of normal for you to utilize in your disaster recovery plans. Evaluating the needs of environments and architectures, assessing how to implement high availability and fault tolerance, and determining how and when to implement disaster recovery strategies make up the major themes for this section. And while it's not primarily service specific, it is important for you to understand these concepts and how various environments would implement them based on needs of the organization. Goodbye for now.